I'm going to explain how trigonometry works with sine, cosine, tangent and all that stuff. But first you have to identify the parts of the triangle. Of course we're talking about a triangle of 90 degrees. It has to be 90-degree triangle. Otherwise, if you have a triangle like this, it's not going to work. It has to be 90 degrees. 90 degrees. And then we can use all this theory that we're going to talk about. So this is only for 90-degree triangles. We have to identify the parts of the triangle. If we're talking about this angle here, the angle phi, then this line here is called the adjacent because it's sitting next to the angle. It's touching the angle, the adjacent. The opposite is the one that's in front of the angle, opposite side. This is called the opposite. Now if we want to change the angle, like for example, we're going to change the angle that we're going to talk about over here. This is going to be angle phi. Then this of course is going to change here. This line is going to be the opposite and this line is going to be adjacent. But in this case we're going to talk about this angle, so I don't have to change everything. Now the sine of angle phi, the sine of this angle equals opposite divided by hypotenuse. So remember, sinus is always, you start with opposite divided by hypotenuse. Cosine of the angle phi is the other one, it's adjacent divided by hypotenuse. Adjacent by hypotenuse. So remember that the first part is always opposite divided by hypotenuse. The second one is cosine, it's adjacent divided by hypotenuse. Then the tangent is this one divided by this one. Just eliminate the hypotenuse, then you have opposite divided by adjacent. So it's opposite divided by adjacent. Now we also have cotangents. Secants and cosecant. This one is the same as this one, just only opposite, upside down. So it's AD, adjacent, divided by opposite. The secants is the same as this one, just upside down again. That's hypotenuse divided by adjacent. And the cosecants is the same as this one, upside down. That's hypotenuse divided by opposite. That's it. That's all the trigonometry that you have to know. So let's do some examples. I'm going to leave the formulas. The ones you're going to use most is the first three here, so I'm going to get rid of these ones. Okay, let's get an example here. This one is 3 inches. Of course here we have 90 degrees. That's 90 degrees here. And this angle here is 30 degrees. And now we have to find this is line A, B and C. So we're going to have to find C is and B, the length of B, the length of C, and then we have to find the angle phi. So now we're going to try to use those formulas here. We have this angle and we know the opposite. We have angle, opposite, we can use this formula here. We have opposite here. And we have opposite here. So we can use either one. We can use this one or we can use this one. So here in this we know the angle, the sinus of 30 degrees equals opposite, that's 3 over hypotenuse C, we don't know that one. Here we have the tangents of 30 degrees equals opposite 3 over AD, 3 over adjacent, that's B. So now we need a calculator to calculate to find the sine of 30 degrees. Sine is 0.5. So 0.5 equals 3 over C. So that is, we can change C, and C is 3 over 0.5 is 6. Now we're going to find B here, the tangent of 30 degrees. Is 0.58. So 0.58 is 3 over B. So B is 3 over 0.58 equals 5.17. So here's the answer. B is 5.17. C is 6. And the angle here is 90 degrees minus 30 is 60. Yes. The total of angles in one square is 180 degrees. We already have 90 here, so that leaves us 90 minus 30. 90 minus 30 is 60 degrees. So this one is 60 degrees. Now we can test our results with the Pythagoras law that says that a squared plus b squared equals c squared. So 3 squared plus b squared equals 6 squared. Then we know that our result was, our findings here are correct. So 3 squared is 9 plus 5.17 squared, 26.73 equals 36. So let's add 26.73 plus 9 equals 35.73. 35.73 equals 36. Well, that was pretty close. Because those sine and cosine, those numbers, they are, like here, they are rounded off, you know. It's 0.58 and some whole bunch of more numbers, so it's never going to be exactly correctly, but it has to be very close. Okay, let's try another one. Okay, now we're going to do the next one is this one is 5 inches. This one is 7 inches, and we want to find the angle phi here. We don't know what the angle is here. So what we have here is the angle. We have the opposite, and the hypotenuse. Opposite hypotenuse, that's this one here. So we're going to use this formula. Opposite hypotenuse, yeah, that's the only one we can use. So sinus, or angle that we don't know, equals opposite. The opposite of this angle is 5 over hypotenuse is 7. So 5 over 7, 0.71, 0.71. Now we have to find the angle that corresponds with the sine of 0.71. So we have to look up in our tables or your calculator and see what the angle is. So the angle is 45.23 degrees. Now we can find this side here. So we know the angle, we know any one of these. So this angle, this is the adjacent, opposite, adjacent, opposite. We can use this formula here to find this here. So the tangent of the angle is 45.23 degrees equals opposite 5 over, let's call this line the line A, 5 over A. The tangent, this time tangent of 45.23, 1.01. So 1.01 is 5 over A. A equals 5 over 1.01. 5 over 1.01 equals 495. A is 495 here. Okay, now we know all three sides of the angle. Let's check it again with the Pythagoras law. 5 squared plus 4.95 squared, 5 squared per this squared equals this squared, 7 squared, 25 plus 4.95. 2450 equals 49. Let's find out. 25 plus 2450 equals 4950. 4950 equals 49. See, it's never going to be perfect, but it's going to be very close because of that. Say that these numbers here, the tangent is 1.01, it's 1.01456, whatever, I don't know, a whole bunch of numbers, so it's never going to be perfect. But you have the idea how to do it, and I hope you understood what I was explaining here, and you can figure it out yourself now. Thank you for watching.